So remember, first thing we're going to do is factor, right? So I'm going to factor the top. And it factors y plus 5 and y plus 5. And then y times y plus 3. All over y plus 3 times y minus 3 times y plus 5. And then I make some ones. So I've got a y plus 5 and a y plus 5 and a y plus 3 and a y plus 3. And that leaves me with y times y plus 5 over y minus 3. And you usually don't multiply these back together. You just leave them in factored form. Even though I know it says multiplication, you just leave them in factored form. Okay? And then the next one, I'm going to factor again. And for the first one, I get 5x minus 2 and 5x plus 2. And then this is division, so I'm going to flip this one. So this is x plus 3. And then x plus 3 and x minus 3 and 5x minus 2. Make some ones. I got 5x minus 2 and 5x minus 2, x plus 3 and x plus 3. So 5x plus 2 divided by x minus 3. Okay, beautiful. And then the next one, I'm going to factor this puppy. And if I take an a out of this, I get a times a squared minus b squared. So that becomes a times a minus b and a plus b. And then the second one becomes 2a minus b and 2a plus b. And then I flip the last one, and that's a minus 1. And I'm going to factor the bottom. And 2a is just 2a and a. And b squared is just b and b. And then that's pluses. Okay, and then I'm going to factor the middle one. A factors to a, and b squared is b and b. And I need a negative 2 in the middle, so that means they're both negative. Then I'm going to factor out an a, and I get a plus 1. Beautiful. Now I'm going to make some ones. So the a goes away. A minus b. Oops, I think this is supposed to be an a plus b. And an a plus b and a 2a plus b. And I think that's it. So my answer should be, and again, I don't have to multiply this back out. I can just leave it in factored form for the multiplication one. So this is 2a minus b times a minus 1 all over a plus b times a plus 1. Done. Any questions? Awesome. Okay, so now we're going to move on to the little bit harder one, which is adding and subtracting. Of course, the first one we're going to do is, it says perform the indicated operation and then simplify when possible. So the first one we're going to do, I'm so sorry, as if my denominator is the same. So just like adding fractions without variables, if your denominator is the same, I can just add my numerators, right? So number 1, my denominators are the same, so that means I just need to, so my denominators are the same, so I just need to add the tops. So that means I get 10 over 5n, and then I need to simplify, so that becomes 2 over n. Is there any questions about that one? Or how we add yet? Okay. Then if I go to the next one, my denominators again are the same. I have x plus y and x plus y. So that means I'm just going to combine my like terms in my numerator. So I'm going to get, let's see, x plus x is 2x, and negative 3y plus 5y is plus 2y, all divided by x plus y. And then I can factor the top. I can take a 2 out of the top, and I get x plus y over x plus y. And then those make a 1, so my answer is 2. Questions? Are we okay? Okay, so I'm going to keep going. So again, my denominators are the same. So in this time, I have a subtraction problem. So I want to make sure that I know that it's subtraction. So I've got 5a minus 6a, which would give me negative a, and negative 4 minus a negative 11. So that's going to give me 7 plus 7. Yes, plus 7. 7, 8, 9, 10. Yes, okay, plus 7, sorry. And then I'm going to, then I get a squared minus 6a minus 7. And then I'm going to factor this just to make sure that I can't simplify it. So I'm going to factor a negative 1 out of the top, and I get a minus 7. And then the bottom, let's see, factors 2, a and a, negative 7 and plus 1. So those go away. So I get left with negative 1 over a plus 1. Questions? Okay, so now it's going to be your guys' turn. I've got 4 problems for you to add. And okay. So I've got, let's see, what do I have? A plus 5a is 6a, and negative 4a plus a negative 5a is negative 9a over 30a cubed. And then I can factor a 3 out, so I get 3, nope, not 3, 2a minus 3a all over 30a cubed. And then 3 goes into 3 once and into 30 10 times. So my answer is going to be 2a minus 3a all divided by 10a cubed. Good job. And then the next one is a subtraction problem. Right, so x minus x is 0. And then negative 6 minus a negative 2 is negative 4y over 10y squared x. So 2 goes into 4 2 times and into 10 5 times. And this y goes away, and then I have 1 left on the bottom. So I get negative 2 over 5 yx, I guess, xy, however you want to put it. There you go. And then, oops, here we go. Same denominator again, add, so a plus a is 2a, and then minus 10b all over 10a squared b. So I can factor a 2 out, and I get a minus 5b all over 10a squared b. And 2 goes into 2 once, into 10 5 times. So I get a minus 5b divided by 5a squared b. Whew. And the last one is a subtract sign. So I'm going to get v minus v is 0. And negative 4 minus a minus 5 is 1. And since there's nothing that 1 will go into, I can just leave the denominator the same. 6v cubed plus 18v squared. If you factor the bottom, that's awesome too. If you put 1 over 6v squared times v plus 3, I almost put 2, plus 3, that's fine. Also, either one is correct. Okay, any questions? You guys did good. Everyone's putting stuff in the chat's doing good. Okay, yay. Okay, so now we're going to move to something that's going to help us with the with unlike denominators, and they just want us to find the least common multiple of each pair. Well, a pair. Sometimes there's more of each set of polynomials. So basically, I want to find the biggest thing that all of them go into. So what's the biggest thing, not the biggest thing, sorry, the smallest thing that both 5y and 8y cubed go into. So first I'm going to look at, for me, the first thing I look at are my numbers. So what does both 5 and 8 go into? That one's pretty easy because we know that both 5 and 8 go into 40. Okay, and then we're going to take a peek at the variables. So that one's just a little tougher to look at. I need the smallest amount of y's that both y and y cubed go into. And the smallest amount of y's that they both go into is the one with the highest variable. Okay, so that would be y cubed. So my answer would be 40y cubed. And if I was trying to find a common denominator, and those were my denominators, that would be my common denominator, 40y cubed. Okay? Please make sure you're asking questions on this, okay? Because we're going to start adding fractions with unlike denominators pretty soon. Okay. So now what happens if it's not just if we have add and subtract signs in there, right? So like number 2. So the first thing we're going to do is factor it. So I want to factor both of my expressions. So on the first one, I'll have x plus 3 and x minus 3. And then my second one would be, multiply to be 9, add to be -6, negative 3x minus 3 and x minus 3. Okay? So this one's a little harder. I don't know. Sometimes I think it's a little harder. You guys might not think so. I need, whatever my common denominator is, it has to have whatever's in both denominators. So I usually just start with 1, and I know that, okay, so I'm going to start with this. So my common denominator has to have that in there. So it's going to be x plus 3 times x minus 3. So then I ask myself, what does my common denominator, oh my gosh, I can't even talk. Common denominator need that this one has. Okay, so in the second expression, I have 2x minus 3's, but my common denominator only has 1 x minus 3, which means I need another x minus 3 in my common denominator. So that would be what I need. Another way to kind of think about it is, what does this one have? What does this one need that this one has? And what does this one need that this one has? So that's another kind of way to think about it. They just have to have everything that's in both terms, or all 3 terms. So I want you guys to try. Let's just try, I'm going to put them all 3 up there and see how you do, but make sure you ask questions and we'll see how it goes. Through these. Wow. So on A, I need a number that, one number that 30, 40, and 60 go into. And so instead of thinking of 30, 40, and 60, I just thought 3, 4, and 6. What's a number that 3, 4, and 6 all go into? Which is 12, right? 3, 4, and 6 all go into 12. And then I added the 0 back on there. So I know that this one will be, for the numbers, 120. So 30 goes into 120, 40 goes into 120, and 60 goes into 120. And then now I need to look at the variables. So at U, I need to find the U with the highest variable, highest exponent. So that would be U to the 6th. And then the V with the highest exponent is V squared. And then the T with the highest exponent is T to the 4th. Okay, questions? And we're going to do the same thing with number B. There's no number, so I don't have to worry about a number, but I'm just going to worry about the variables. And I'm going to find the variable with the highest exponent for each one of them. So A is just A, because there's no power to any of them. And then B would be B to the 6th power. And C would be C to the 5th power. Okay? And then the last one, I messed up when I was doing it because I did not see this, but somebody helped me see it, so thank you. I can, out of the first expression, I can factor a 4. So if I factor a 4 out, I get x squared minus 4. And then out of the second expression, I can factor a 6. So I get x squared minus 4x plus 4. And now I'm going to factor again. So I get 4 times x minus 2 times x plus 2. And then the second one becomes 6 times, 6 times x minus 2 and x minus 2. Awesome. And actually, Mitchie, you might be right because I think I was thinking wrong again. This one's just killing me. So what does both 4 and 6 go into? Of course, it's 12. Wow. Okay, so 12. And then this, the first one, if I look at the first one here, I need an x plus 2 and an x minus 2. And then what do I need out of the second one? Another x minus 2. So that'd be x minus 2 squared. Duh. So yeah, nice job, Mitchie. Beautiful. Okay. There we go. That would be my common denominator. Okay, so now we're going to go to adding and subtracting with unlike denominators. And we're going to start out easy, and then we're going to work our way up. No, you did great, Mitchie, so that was awesome. We're going to start out easy, and then we're going to work our way up to get a little harder. So there's a couple ways you can look at this. How do I want to say this? Sometimes I can't think of how I want to say stuff, you guys. So what is my common denominator? I just want to start there. What's my common denominator? So I have 15x squared and 5x. So what's the biggest number that both 15 and 5 go into? Which is 15. And then it would be x squared. So now I want to ask myself, what does this denominator need that's in my common denominator? What do I multiply that denominator by to get my common denominator, I guess I should say? And nothing. I don't need to multiply anything by, right? So I'm just going to I am going to multiply by 1. So it's just multiplied by 1, okay? Because I don't need to change it. It's just going to stay the same. And then I'm going to ask, what do I need to multiply this denominator by to get 15x squared? Well, 5 times 3 is 15, so I'm going to multiply by 3. And then I need another x. So, right? So if I multiply by 3x times 5x gives me 15x squared. And then I'm going to multiply by the same thing on top. So I'm just multiplying by 1, so that doesn't change. I'm just making it look differently. So, yeah, let me not write it this way. Let me write it this way. That's what I want to do. So this becomes 2 over 15x squared plus 9x over 15x squared. Now these are just like the first problems we did with the same common denominator. So I'm going to get, what am I going to get? 2 plus 9x all over 15x squared. And I can't do anything else to that, unfortunately. Just so you know, some of these get really ugly because like the ones we did at the beginning that could simplify really easy, a lot of them don't do that, just so you know. So, okay, another way to look at this, I just want to kind of, I'm going to do it this way. So another way to look at this, because I have two fractions, I can multiply everything together. And this is kind of how sometimes I do it with just number fractions. I just multiply everything together and then simplify at the end. So sometimes that's a way to look at it. So I'm going to multiply 2y times 2xy, and that's going to be minus 5 times 2x, and that's a better way to write it. I'm going to multiply each top times the opposite bottom. So basically, I'm going to cross multiply, okay? And then the bottom times the bottom. So 2x times 2x, and that should be a y. 2xy. Okay? So there's two different ways to think about it. The way we did it the first time for number 1 and the way we're doing it this time. So now let's multiply everything together. And we're going to get, let's see, 4xy squared minus 10x all over 4x squared y. And now I can factor everything out and simplify it. So let me move this over just a little bit. You guys can see it, but I'm running out of room on my iPad. So I've got, what goes into 4 and 10? 2 and an x. So I can take a 2 and an x out, and I get 4y, no, not 4, 2y, 2y minus, 2y squared minus 5 all over 4x squared y. And then I can simplify from there, right? 2 goes into 2 once, into 4 2 times. There's 1x on top and 2 on the bottom. So my answer should be 2y squared minus 5 all over 2xy. That's it. Okay, so either way you want to do it, I don't care which way you like, just choose one and solve. Either way works. So I can either get my common denominator and then and multiply that way, and then with my common denominator I usually do not have to simplify, or I can just kind of cross multiply and then multiply the denominators together and then simplify. Whichever you want to do. Okay, so I'm going to go ahead and have you guys do A and B. Now I'm going to tell you right now that on A, it's a little harder to do the cross multiplication one, but I want you to try it. So actually on both of these, I think that I would just kind of try and find out what the common denominator is on both of these. So I know on the second one, I would factor out a 2, and this becomes x minus 2. So the first, what does the first denominator need that the second one has? Well, is a 2. So that means I'm going to multiply by 2 over 2. And then what does the second denominator need that the first one has? Nothing. So that one is fine. I'm going to leave that one alone. So that means this equation becomes 2x plus 2 over 2 times x minus 2 minus x minus 1 all over 2 times x minus 2. Is there any questions about that? Awesome. So 2x minus x is 2x minus oh my goodness, 2x minus x is x. Just lost it for a minute. And then 2 minus a minus 1 is plus 3 all over 2 times x minus 2. Done. Okay. And then the next one, I'm going to ask myself the same question. What does the denominator in the first term need that the second term has, which is n squared, which means I'm going to multiply the top by n squared and the bottom by n squared. And then what does the second denominator need that the first one has? Nothing. So I can say I'm going to multiply by 1 over 1 if you want. You don't need to. So that's going to equal 3mn squared all over 5n squared plus 5 over 5n squared. 5. So once I add them together, I get 3mn squared plus 5 all over 5n squared. Done. Okay? So we go to the next set. Beautiful. So what does the first denominator, so there's not a denominator on 4. Can I write 4 with a denominator? I can write any whole number as a fraction by putting 1 underneath it, right? So you guys know that. So like with slope, same thing. As long as it's a whole number, I can write it as a fraction by just putting 1 underneath it. So now I want to say, what does the first denominator need that the second one has? And that would be x plus 1 divided by x plus 1. So I want to multiply by 1 so it doesn't change anything. And then what does the second denominator have that the first, what does the first denominator have that the second one needs? Nothing. So again, that's 1 over 1. So if I refigure this out with it distributed out, I get 4x plus 4 all over x plus 1 plus x minus 3 all over x plus 1. So that gives me 5x minus 2 all over x plus 1. 1 minus 3, yeah. Okay. And then number 2, again, I'm going to factor the bottom part. So I'm going to factor out a 3a, and then I get a minus, oh my Lanta, a minus 3. So this one's going to get kind of ugly. I'm not going to lie to you, okay? So what does the first denominator need that the second one has? Well, it needs everything. So I think on that, because there's nothing in common on these ones, I am not going to use the factored one because there's no 2 in it and it's just kind of ugly, and I'm going to have to multiply it back out anyways. So what does the first denominator need that the second one has? Well, everything. 3a squared minus 9a. And then what does the second denominator need that the first one has? Well, the 2. So now I'm going to simplify everything, or, well, multiply everything out, not simplify yet. So I've got 15a cubed minus 45a squared minus 2a plus 6. So I did the minus through there. All over 2 times 3a squared minus 9a. I can't factor anything. I can't factor 2 out, can't factor 3 out. Okay, so I can't factor anything out of the top. Can we factor by grouping though? We might be able to factor the top by grouping. So let's see if we can do that. So if I factor a 15a squared out of the top, I get left with a minus 3, right? And then if I factor a negative 2 out, I get left with a minus 3. That's beautiful. And on the bottom, I have 2 times 3a gives me a minus 3. Okay, that's beautiful. Whew. Okay, so I'm going to be able to factor something out. That's good. And I might run out of room, though. So I've got 15a squared minus 2 times a minus 3. And then I'm going to say this is 6a times a minus 3. So those go away. So I get 15a squared minus 2 all over 6a. Wow. Okay. That was bad. It wasn't really bad. You guys can do it. I know, Jordy. Trust me. Okay. I'm going to leave those there. I want you to go ahead and do this one. So these two are a little different. Notice that there's whole numbers. I tried to get, I guess I didn't really do the best job trying to get questions that were similar to each other. I tried. I guess I didn't do a very good job together. But what I'm going to do on this one is I'm going to still ask the same question. What does this denominator need? What does this denominator need that this one has? Well, a 5. So I'm multiplying by 5 over 5, right? The top needs if I'm putting a 5 in the denominator, I need to put a 5 in the top. And what does this denominator need that this one has? Well, the 2v minus 1. So I don't want that to change, so I'm multiplying by 1, right? Just a special 1. So I'm multiplying by the same thing. So what I end up getting is 5 times v minus 3 all over 5 times 2v minus 1 plus 6 times 2v minus 1 all over 5 times 2v minus 1. Now I have a common denominator, okay? And I'm going to distribute, right? So I get 5v minus 15 plus 12v minus 6, okay? All over, and I do not have to multiply. I don't know why I put that in parentheses. I don't have to multiply the denominator out. I can just leave it in factored form. So I've got 17v minus 21 all over 5 times 2v minus 1. And that's it. Okay? So you just have to ask yourself, what does the denominator have? What does this denominator have that the other one doesn't? Okay? So what does this one have that this one, what does this one have that this one doesn't? And what does this one have that this one doesn't? And I'm going to multiply both the denominator and the numerator by that. So this needs a 3x minus 5. 3x minus 5. And this one needs an x minus 4. X minus 4. And an x minus 4. So I get, let's see if I can, 5 times 3x minus 5. Minus 3 times x minus 4. All over 3x minus 5 times x minus 4. So I get 15x minus 25. Oh, yeah. Okay. Minus 3x plus 12. All over the factored form of 3x minus 5 times x minus 4. And then this simplifies to 12x minus 13 all over 3x minus 5 times x minus 4. All right, good job. Okay, so let's go to, do I need to pause for a second? Or can I go to the next page? I need to pause for a second? Okay.
So you don't like distribute the special one. You just kind of, for lack of better words, cap it off.
I did distribute. Oh, you mean on the bottom or on the top?
On the top.
I did distribute it. See, when I went from this step to this step, I distributed it. I just wrote it first before I distribute. So I did 2 steps.
Okay, because I kept trying to distribute it, and then I got lost whenever you started.
Yeah. So I just rewrote it here. So I just rewrote it so it looked neater, and then I distribute it. If I was doing it on my paper, Emma, I would just distribute it. I would just kind of skip this step and go straight to this one and just distribute it and then add it there. Does that make sense then? Did that help a little bit? Yeah. But I'm just trying to, because some people get mad at me for skipping steps that I think are obvious, and some people don't think are obvious. So I try and not skip steps.
It's okay. After you explain it, now I understand.
Okay, good. Okay. Can I go on now?
Yeah.
Okay. All right, so we have the last few problems. They're getting a little harder as we go along, unfortunately. So these two, and I just want to say this, I'm pretty sure that you don't have any like this on your homework. I just want to put that out there. Most of the ones on your homework are like the last ones we had, but you will see these, especially next year when you go to college. Just going to throw that out there. That's why we're going over them. Okay, so I'm going to factor this bottom one, this one first. So this would be x minus y and x plus y. So what does this denominator need that the other one has? Nothing. What does this denominator have that this one needs is the x, I wrote too small almost, x plus y. Okay. And then I'm going to rewrite it. So I've got 6xy all over x minus y and x plus y minus x plus y and x plus y all over x minus y, x plus y. And now I'm going to multiply the top out, because I do have to multiply the top out because it's, oh, there is one on the homework? Okay, great. Because I do have to multiply the top out so I can combine the like terms. I can't talk today. So I'm going to get 6xy minus, let's see, x squared plus xy plus xy plus y squared. Beautiful. All over the common denominator. I'm going to leave the common denominator off for just a second so I make sure I have room to do this. I hope you guys are okay with that. So if I put my like terms together, I'm going to get negative x squared. This is a negative and a negative. Plus 4xy minus y squared. Just so you know, that does not factor to anything. All over x minus y, x plus y. Because I can't get ones to add to 4. Imagine that. Okay. That one wasn't too terribly bad. I think the next one's going to be a little worse. Okay, so I'm going to factor the denominators again. So let's see. I think this is going to factor to x plus 5 and x plus 6. I'm going to make this bigger so you guys can just see it better. Is that okay? Plus, it's easier to write if it's bigger. And then this one factors to x plus 4 and x plus 5. Beautiful. Okay, Let me fix this one really quick. Okay. X plus 6 and x plus 5. Okay. So what does this side need that this one has? Well, it needs an x plus 4. And what does this side need? It needs a x plus 6. Okay. So then if I rewrite it, I get x times x plus 4 minus 5 times x plus 6 all over my common denominator, which is now x plus 4 times x plus 6 times x plus 5. Ugly. Okay, so that's x squared plus 4x minus 5x minus 6. And again, I'm just going to deal with the top right now because my common denominator is not changing right now. So x squared minus x minus 6. And I think I should be able to factor that. So that factors to what? Minus 3 and plus, minus 3 and plus 2. Yeah. All over. I thought it would simplify, but of course it's not going to. X plus 4, x plus 5, and x plus 6. Ooh, that's ugly. And that's what it equals. Beautiful. That is not what it equals. I messed up. Because 5 times 6 is not 6. Wow. Okay, let's erase there. 5 times 6 is negative 30. Let's see if that will make a difference. Minus x minus 30. I think that's going to be better. Okay. X and x, negative 6 and plus 5. That is better. So I'm going to get x minus 6 over x plus 4 times x plus 6. Okay. Multiplied wrong. Beautiful. Okay. There we go. That's a little better. Still ugly. Okay. And then the last problem. How are we doing on time? We are not doing well on time. So I think what will happen is we'll end with this problem. Actually, I think we'll end with that last problem. I'm so sorry, you guys, because we only have 7 minutes left for you to even start on your homework. So we're going to end there. I will